Hello and welcome to Simplified Triple Studies. Let us continue the discussion on the previous year question of Kseb sub-engineer examination. The previous video link is included in the description box and I button. Kindly go through that. Let us continue the discussion. Before going for the discussion, I would like to display the questions which I am going to prepare in this session. So you can see the question. So if you want to post the particular video and answer it accordingly, fine. So I am scrolling down. I think you can see, you can read my handwritings. Yes, these are the various questions which are repeated in the year of 2013. So kindly mark it appropriately. So whenever I'm going to explain, so it will be easy for you to do the self-evaluation. So these are the questions which I'm going to discuss in this session. Okay. Yes. There are 73 from 55 to 73. There are these many questions are there. Let us briefly explain individually. Fine. Yeah. So let me go ahead with question number 55. You can have a look on this. So let me use the marker. Read the question. If the rotor of three-phase induction motor is fed from balanced three-phase supply with the stator short-circuited, then the frequency of the stator current would be. How does induction motor work? We are applying a three-phase. We are providing a three-phase supply at the stator side. There is a production of rotating magnetic field. That particular rotating magnetic field is interacting with the rotor conductor. As a result, an EMF is induced in the rotor conductor. This is responsible for creating a driving force. That is an EMF that will be creating over there. So then if the rotor conductor is closed, the current started flowing that particular conductor and thus it starts operating. So it's basically based on Faraday's law of electromagnetic induction. But the question is, if the rotor instead of supplying the stator, if the rotor is fed with the three-phase supply, so what could be the frequency of stator current? So remember that there is a general equation of rotor, that is F dash is given by S into F. What is F? F is nothing but slip, right? It's a difference between the synchronous speed and the actual speed to the synchronous speed. Ns minus N divided by Ns, slip. So F is the supply frequency. So remember that despite of providing, regardless of providing the three-phase supply, the stator and the rotor, the equation remains same. F dash is equal to S into F. Either it may be in the form of rotor side or it may be in the form of stator side. The equation remains unchanged. The right answer is F dash is equal to S out. Kindly select option A. Option A is the right answer. Please read the question number 56. In a three-phase induction motor, the mechanical power developed in terms of air gap power PG is. So you need to remember one thing. We can say that P2. Let us P2 is the rotor power. I'm going to mention P2. Let us consider P2 is a rotor power, right? So next PCU. PCU means copper loss. Okay, copper loss at the rotor side. PCU. Okay, copper loss obviously happening at the rotor side. Next mechanical loss, that is denoted by the letter PM. PM is the mechanical, not mechanical loss. It's a mechanical power developed at the rotor. So three terminology you have to remember. P2 is to PCU is to PM. Okay, so there is a one relation. These three parameters, if you take like P2 means rotor power, PCU means rotor copper loss, PM is the mechanical power developed. There is one relation like 1 is to, correct? 1 is to S is to 1 minus S. Here S is known as slip. Suppose if the rotor power is 1 watts, you can multiply throughout 1. Understood, no? So therefore, the mechanical power developed in terms of air gap power. So what you can write is PG into 1 minus S. That means you can take example of 1 watts. Okay, you have to multiply throughout 1. So same manner, if you consider the mechanical power developed in terms of air gap power PG is given by that PG into 1 minus S. PG into 1 minus S. The right answer is option B. I think it's clear to everybody. You have to remember this ratio any cost. Just remember this. P2 is to Cu is to Pm is equal to 1 is to S is to 1 minus S. I think it's clear to all. Kindly go through question number 57. The hunting in synchronous machine can be guarded by. So which is what is hunting? Hunting is actually happening in case of synchronous motor. Suppose suppose a synchronous motor, consider the synchronous motor, it will be operating at the synchronous speed. If you are providing the load at any instant, definitely there is a changes in the load angle. So that is referred as hunting. The hunting may affect the static, right? So to overcome the problem of hunting, what you can do is you have to use damper winding. To minimize the hunting, damper winding is the one of the best choice. It balances the changes in load angle. So the starting issue can be mitigated by providing the suitable damper winding. So you can go ahead with the option number C. Please read the question number 58. The power in a three-phase circuit is measured with the help of 2 wattmeters. The reading of 1 wattmeter is positive. So you can note down W1 is positive. Okay. And other is negative. Let us write it W2. W2 will be negative. Correct. The magnitude of reading is different. Oh, of course, it can be concluded that the power factor of the circuit, by checking the wattmeter reading, you can predict the power factor. It can be concluded that power factor of the circuit is, which is the right answer. So before solving this, I would like to tell you 2 equations. So you can note down one equation. The tan phi is equal to square root of 3 into W2 minus W1, W2 minus W1 divided by W1 plus W2. This equation you have to keep in your mind. This is very important equation. So where W1 is known as, you can write root 3 VL into IL into cos 30 plus 5. Cos 30 plus 5. Conversely, you can write W2. W2 can be written as square root of 3 into VL into IL into cos 30 minus 5. Cos 30 minus 5. This point you have to remember, right? Okay. So based on this, you can make a conclusion. So we can have a table. If you want, you can write one table. Suppose if the power factor is less than, in this fashion, power factor is at 0.5. Okay. The condition is W1 will be positive. W1 is positive and W2 will be negative. That means W1 is greater than W2. So the overall power we may get positive. But the thing is here, if you talk about this condition, we can say that the power factor is actually less than 0.5 lagging. Power factor is less than load power factor. Operating power factor of the load is 0.5 lagging. I think it's clear to everybody. So you can make use of the different conditions by using the equation. I did the same manner. Let us read the question number 59. The aqueduct is used in CRO to collect dash primary electrons, secondary emission of electrons, both primary and secondary emission of electrons, none of this. So purpose of aqueduct is to collect the secondary emission of the electrons. So please select option B. Very important. So you have to remember about CRO, the components of CRO. Before going to the examination, kindly go through that. Fine. This point you must remember. The short circuit test on transformer is to conduct to obtain. If I talk about a short circuit test, obviously it is the purpose of measuring the copper loss. Total copper loss will be measured. If I talk about the OC test, it is mainly used for core loss. Short circuit test is for measuring copper loss and open circuit test is used for measuring the core loss. Question number 61. At the initial condition, T is equal to 0. So you can consider one inductor. Okay, one switch also you please consider. Now suppose we are providing a supply. Okay, we are providing a supply. This is your inductor. Fine. So there are two. Initially, what I can say, there is a immediate changes of current. Okay, that particular duration is known as transient behavior or transient period. So afterwards it becomes steady. That is called a steady state behavior. So in the initial condition, so at the time of initial condition, we can say that the inductive reactance become very much high. at the beginning during the time of the transient condition. So you already know that inductive reactance is nothing but L into 2 pi f, where L is known as value of inductance, F is the supply frequency. So we can write XL is directly proportional to supply frequency. As during the transient period, XL is very high, in proportional, the frequency is also very high. So for such cases, we can say that at the beginning, it will act as an open circuit condition. Okay, initial condition, the inductor will act as an open circuit. That is the right answer. I think it's clear to everyone. Everybody please read 62, question number 62. This question is from microcontrollers. To address 1 megabyte memory, 1 megabyte means you can convert into kilobyte. It is around 1024 kilobyte. Not kilobyte, kilobit. Remember that, kilobit, KB. How many addresses lines are needed? Addresses line means 2 raised to n. Here, where n is known as the number of lines, address line, 2 raised to n. N is the address line. I think it's clear to everybody. So initially what you can do is, this KB can be written in terms of byte. So this much of KB can be written as 1024 into around 1024, 1024. So in mathematics, you must have studied 1024 is nothing but 2 to the power 20. You can remember this formula, 2 to the power 2 to the power 10, right? Not 20, 2 to the power 10. This also will be 2 to the power 10. So 1024, it can be written as 2 to the power 10 into 2 to the power 10. What is 2 to the power 10? 2 to the power 10, again, 1024. If you multiply, you will be getting 2 to the power 20. It can be compared with the equation like the number of address line, 2 to the power n. So n and n can be compared. Therefore, the value of n will be 20. Of course, n is equal to 20. Here, what is the right answer? You can check the answer. Is it available or not? Here, the value of n can be selected as 20. I think it's clear to everybody. Yes or no? Let us move on to the next question. The fastest logic family. Usually, ECL is the fastest logic family. Please select option D. Another question. The leakage current in the semiconductor diode is caused by, which is the right answer? It is mainly due to heat energy. Okay, heat energy. The activation of molecule, everything you can talk. How it is influencing. Okay. Please read question number 66. Dash is defined as the time required to complete the operation of accessing entire memory or input-output. Actually, the machine cycle. The machine cycle is defined as the time required to complete the operation of accessing either memory or input-output devices. Which one is non-resonant antenna? You need to study some basics of antenna. So the example of non-resonance antenna is rhombic type antenna. Please select option C. Option C is the correct answer. So you have to study the basics of communication, modulation, demodulation. Okay, some fundamentals you have to remember. Question number 68. A carrier is simultaneously modulated by 2 sine waves with modulation indices of 0.3 and 0.4 respectively. The total modulation index. The total modulation index you can calculate it by using the formula. Square root of m is nothing but m1 square plus m2 square. Okay. Now you please calculate what is the final answer. m1 is 0.3, no? 0.3 the whole square plus 0.4 the whole square. 0.4 the whole square. It is nothing but 0.25. So 0.25 is nothing but, what is the answer? 0.5. So the total modulation index will be option A, 0.5. I think it's clear to everybody. Yes or no? Question number 69. It is related to the question from mobile communication. Channels responsible for initiating mobile calls. So you need to understand about the basics of mobile communication. Here you need to know about mobile station and base station. Okay, there is one base station and there are different mobile stations. There is a mutual communication between mobile stations and base station. So obviously we can say that there is a forward control between mobile station with the base station. Also, there is a communication between base station with the mobile station. So we can say that initially there is a forward voice control. Okay. Afterwards, reverse control channel also will be there. Forward control and reverse control channel. Forward control channel and the reverse control channel. Okay, two control channels will be there. One is forward control channel, another one is called reverse control channel. From this, I feel question number C is the option number C is the appropriate one. So go ahead with the option C. There is a forward control channel and a reverse control channel. Forward and reverse control channel. Okay. Question number 70. Which one is not the advantages of negative feedback? So you study about the fundamentals of negative feedback, why negative feedback is required, what is the importance. If you look at this particular question, it is very clear that if you go for negative feedback, bandwidth would have been increased, but they have written as reducing the bandwidth. So obviously the right answer is D. D is the right answer. Let me discuss question number 71. In optic fiber communication, the light signals are sent from one end to another end by, which is the phenomenon, refraction, diffraction, then absorption, total internal reflection. Obviously, we can say that the total internal reflection is the correct answer. Okay. Let me discuss question number 72, a numerical. Find beta DC of a transistor having the alpha DC is equal to 1.98. So there is a formula between alpha DC, both are gain only. Relation between alpha DC and beta DC. Alpha DC, okay. So how to calculate beta DC? If you know the alpha DC. Beta DC is nothing but alpha DC divided by 1 minus alpha DC. If you solve, you will be getting the right answer. So this is the way how to solve this. Question number 72. You can verify it once. Next is, in a PLC, this type of timers has two control lines, count and reset. This type of timer may be started, stopped and restarted without resetting. So first of all, this is dash. So what you are supposed to do is, you need to have a basic knowledge of PLC. I have made a notes on different type of PLC, all those things. If you require, I will share that. Okay, I have already collected in my notes. It's available already there. So PLC timers are off for delay timer, then on delay timer, then a retentive delay timer. Here, from this particular context, in this type of timers, there's two control lines, count and reset. This type of timers may be started, stopped, and restarted without resetting. For this type of timers are known as retentive timer. You can go ahead with the option C. There are few questions remaining. Okay, so that I'm going to discuss in the forthcoming session. Let me know if you are having any queries related to this discussion. Kindly put up in your comment box. Definitely, I'm going to reply. Thank you so much for your patiently listening this lecture video. If you are having any further clarification, please contact me. Have a good luck for your exam point. Have a great day. Thank you.